All right, let's dive into organic chemistry. It can feel like trying to memorize a phone book for an entire country. I mean, there are literally millions of different carbon-based compounds out there. It seems completely overwhelming, right? Well, it turns out chemists have this amazing secret weapon for taming all that complexity, and that's exactly what we're going to uncover today.
So here's the big question. When you're faced with this insane diversity of molecules, how do you even start to make sense of it all? How can you possibly predict how one might behave compared to another? It just looks like total chaos, but there's a really elegant system hiding underneath it all.
And here's the secret, and it's an idea we can all relate to. They sort them into families. Yep, that's it. Just like human families can share a last name, similar looks, or predictable behaviors, these chemical families do the exact same thing. And this one simple concept is what brings order to the whole field.
Now, of course, there's an official scientific name for one of these families. It's called a homologous series. And just like any well-organized family, it's got a set of rules that every single member has to follow. So let's open up that rule book and see what's inside.
Okay, here they are, the 5 golden rules. First up, every member has the same functional group, and we'll get to what that is in just a second. Second, they all follow a single general formula, kind of like a family recipe. Third, as you go from one member to the next, they grow by a really consistent building block, a CH2 unit. Fourth, because of that steady growth, you see these really predictable trends in their physical properties, like their boiling points. And finally, number 5, because they're family, they all tend to react in very, very similar ways.
So let's talk about that first rule, because it's the most important one, the functional group. Think of this as the family's last name, or its most defining feature. It's the active part of the molecule, the bit that really dictates its personality and how it's going to behave chemically. For instance, if a molecule has an OH group hanging off it, boom, it's an alcohol. That single group gives it a whole set of specific behaviors. So if you can spot the functional group, you know the family.
All right, so we've got the whole family structure down. Now let's zoom in a little closer and look at the backbone of these molecules, specifically the bonds holding all the carbon atoms together. This gives us another really crucial way to classify them.
This is the key question here. Are all those carbon atoms connected with just a single bond, or are some of them using double or even triple bonds? This one little difference in bonding creates 2 huge categories that apply across all the families we've just been talking about.
And this slide breaks it down perfectly. Over on the left, you've got saturated compounds. A good way to think about it is that they're saturated with hydrogen atoms. Every carbon is holding on to as many as it possibly can. And to do that, all the carbon-to-carbon links have to be single bonds. Now on the right, you have unsaturated compounds. These guys have at least one double or triple bond between carbons.
So if you're going to remember one thing from this section, let it be this little memory trick. When you see the word saturated, your brain should immediately think single. All carbon-carbon bonds are single. And if you see unsaturated, just think not single. It means there's at least one double or triple bond in there somewhere. That's really all there is to it.
Okay, so we've sorted molecules into families, we've classified their bonds, but you might be thinking, why? Why go through all this trouble? Well, this system of organization isn't just about being neat and tidy. It actually gives chemists an incredible superpower, the power of prediction.
Seriously, just by knowing which homologous series a molecule belongs to, we can start making really accurate predictions. We can predict its physical properties, like what temperature it'll boil at, often without ever having to measure it. We can totally anticipate how it's going to react with other chemicals because we already know how its family behaves. It's what transforms a messy collection of millions of compounds into a science that's coherent, understandable, and best of all, predictable.
And that really brings us to the final, and maybe most exciting thought. This isn't just about putting labels on things. When you can predict a molecule's behavior just by identifying its family and its bonds, well, that's when you can start to design things with a purpose. This is how new medicines get created, how stronger materials are developed, how we make cleaner fuels. The ability to predict is always the first step toward invention. So I'll leave you with this. What would you build if you knew the family secrets?